Hello, everyone. Welcome back to SAT Math Question of the Day. Let's get right into the questions. Introductions will be done later. So here's the question of the day. Please try it, pause, come back, and we will go over how to do it. Okay, a geometry question with a diagram. A right triangular prism with a right isosceles triangular base is shown. The height of the prism is 9 centimeters, and the base of the right isosceles triangle is 8 centimeters. What is the volume of a prism? Well, you have to know that the volume of a prism is the base area of the prism times its height. Now, a prism is basically, Seth can correct me on this, a prism is basically defined as a shape where the base and we have two bases and they are the exact same area. They don't change. So it's sort of like a building, a triangular building, but this building fell. So you can imagine this base here being the basement and this thing here being the roof, and unfortunately the building toppled over.
Well, the way they drew it forces you to read the question. Typically, in school they would show this picture.
Right. Where the prism has
they would put the base on the bottom.
Seth, looks to me like the same picture, frankly.
No, it's vertical. The base is on the bottom.
Right.
Write it like that.
Right.
You know, the base is at the bottom, and then the rest of the prism is above it. Yeah, but here they put the base, the base is standing up on horizontally.
Right.
And the height is really how far it goes back.
Yeah, so the height is generally the length. I like to think of it as the length of the prism.
Well, the trouble is they use the word height.
I know, but it's not a vertical height. The height is really how far.
Well, however you explain it to yourself. The 9 centimeter. They also help you out because the 9 centimeter distance is what they call the height.
Right. Yeah, they do help you. Yeah.
And the base is said to be a right isosceles triangle.
Yes.
And then they have the base of the base.
That's right. The base of the
base. Of the base. The base of the.
That's right.
Base.
That's right. It's very potentially confusing.
The base of the base.
Very potentially confusing. So the way I strongly suggest doing geometry problems is write out the formula first and put the numbers in last. So here's the formula. The volume of a prism is the base area times the height. Now, what is the shape of the base? The shape of the base is a triangle. What is the formula for the area of a triangle? It's 1/2. Now, this is little b, the base of the triangle. Let's say base of triangle times the height of the triangle. And this is all times the height of the prism. What? Am I not sharing? What's wrong?
If you here's your right triangle.
Yeah.
Right?
Yeah. Right triangle, yeah.
Which side is the base?
No, you have to decide now what the base and the height are. We just put letters in there, and we have to use you have to use judgment and figure out what these are.
Yeah, all right, good. So what are you going to use for the base?
Now, I made enough mistakes in my life, and I've seen enough tests in my life to know that this is a right triangle. And in a right triangle.
Okay, it's how a right triangular prism.
Seth, stop.
Hold on. They told you in the diagram
Seth,
which is the right angle.
Seth, So let me talk. I've seen enough problems where if you have a right triangle, the formula for the area of a right triangle is 1/2 base times height. But in this case, it's L1 times L2, the two legs of the triangle, So it's 1/2 L1 times L2. The legs of the triangle are the legs that make the parts of the triangle that make the right angle. So this would be L1 and this will be L2. But then they tell you it's isosceles, which means these two are the same. So this is L1. So the formula really is 1/2 L1 times L1 times, now, I'm just going to put a 9 in there, okay? Because it's the height of the prism. So that's the thing. Now it comes down to what is L1. They don't give us L1. They only give us the hypotenuse. We recognize it's a right triangle. It's the hypotenuse of a triangle. So now you can redraw this if you want. This is L1, this is L1, and this is 8. Now it's your challenge to get L1 given a right triangle. There's probably another formula for the area of a triangle given its hypotenuse, but this is an isosceles right triangle. This is 45. Boy, this really is a geometry problem. And then some people are taught that you could tell immediately what the answer is. The L1 is 8 divided by radical 2. I hate doing it this way. Because it forces you to remember the ratios of an isosceles right triangle. Because the hypotenuse is radical 2 times the legs. So I don't like doing it this way. But it works. But let's say you don't remember that, then you can write the Pythagorean theorem because it's a right triangle. L1 squared plus L1 squared is equal to 8. So 2L1 squared is equal to 8. So L1 squared is equal to 8 divided by 2. Oh, that's nice. If L1's 8 divided by 2. Oh, wow. Wait, is that right? No. It's 8 squared. It's 8 squared. What am I talking about? It's 64. Oh, my God. L1 squared is 64 divided by 2. So L1 is equal to the square root of 64 divided by the square root of 2, which sure enough is 8 radical 2. Oh my God, it is 8 radical 2. So L1 is 8 radical 2. Now we finally throw in all the numbers. 1/2 8 radical 2 divided by 8 radical 2 times 9. And that is...
They'll say 8. It is 8 divided by radical 2.
Did I say 8 times radical 2?
Yeah, you said 8 radical 2.
Oh, I'm sorry. It's 8 divided by radical 2 times 8 divided by radical 2 times 9. Most people do not, I suspect most people just want to get the answer. They don't write it out like this. I think it's so important in geometry problems to actually put the numbers in so that you can see if it looks right, as opposed to just quickly getting the answer. Again, I strongly approached geometry problems with formula all the way, and then put the numbers in at the end. So the final answer is, 64 times 9
Don't multiply the 8s.
Times 2. So that's 64 divided by... I should have done... Well, it doesn't really matter how you do it, but... you have a calculator. But the 64 divided by 2 is 32 times 9 divided by 2. So that's 16 times 9. So it looks like it's 16 times 9 is the final answer. Does that look right?
Yeah.
Is that right? But you're not going to have time to check.
Yeah.
Okay. So 16 times 9 is the final answer. Wow, this is a serious geometry problem because you have to know the formula for the area of a prism. You have to recognize what a prism is. You have to recognize what the bases are. You have to be careful not to get screwed up with the different B's and the different bases because it's so confusing if you don't really understand what's going on. Then you have to figure out the area of a right isosceles triangle given only the hypotenuse. There's a lot of this. What do you think, Seth?
Well, yes, this is a complicated problem. Yeah.
Yeah. Now, we checked the reference sheet that you will get on the digital SAT. You do not get the area of you do not get the volume of this shape. Once we clear the drawings, we'll show you what you do get, but you do not get the area, you do not get the volume of a prism. Yes, you do not get that. You do not get, this is what they don't give you. They don't give you this.
However, it's very easy. It's let's also explain. Let's give let's give a discussion of how it is that the volume of the prism is equal to the area of the base times the height. Here, I will explain it in terms of that red prism that I drew.
Okay.
Imagine that you divide it into little plates.
Yep.
That are 1 unit apart, a stack of triangular plates. Right? The volume of each plate, if the plate is the height of each plate is 1 unit, the volume of the plate, of one plate, is equal to the area of the base. But the height is the number of plates that are stacked up.
Yeah.
And so at least if the triangle is divided, if the prism is divided into unit plates, the volume is equal to the area of the base times the height.
Right.
Now, if it's not evenly composed, regularly composed of unit plates, you could scale it and think of it as many thin plates.
Yep.
But each plate is if you you want the unit height into lots and lots of plates, the number of plates in each unit height is that number you divide it into. And so it all adds up to the same volume.
Right. Yep.
So this figure of stacking up in the vertical direction, height number of thin plates makes it easy to imagine how the volume of a prism is equal to that what's given by the formula.
Right.
Now here's another trick. What if the thing is tilted over? What if it's like this?
Well, that's right. What we have now, right?
Yeah. Then the same thing. The plates are stacked up, except that they are shifted.
Yeah.
So the volume is the same.
Right. Yeah.
It's the volume of the base times
the area of the base.
The height is what's measured perpendicular to the base.
Right. That's right. Exactly. The base and the height of a prism must be perpendicular to each other. And think of a building. Just think of a building with a basement and a roof. And but the shape of the basement and the shape of the roof have to be the same, and it doesn't change within the building. So just basically a circular building like a silo, a corn silo. That's called a cylinder. Okay, what else do they give you in the reference sheet? They are nice to you, though. They give you, in the reference sheet, and we'll show it at the end, in the reference sheet, they tell you the area of a triangle. They give you the area of a triangle is 1/2 the height times the base, and they give you they go like that, okay? We'll show it to you. But they also give you something which is very nice. They give you this relationship here. They give you that relationship for the 45-90 triangle. So just to overlay the colors, this is what they give you on the reference sheet. To help you, they give you this relationship. And then I'll go small. They give you S.
Yeah.
S.
But how do you know that the triangle of this problem is a 45-90 degree triangle?
Good question, because it's called an isosceles triangle. Okay, and they give this to you. And when they say this is 45 degrees, and they say this is 45 degrees. So they give you this thing at the bottom, this yellow relationship. They give it to you on the reference sheet that you can bring up. But all this stuff's not going to help you unless you've done your practice and you've done problems like this before. They may give you everything, but if you don't know how to combine it and use it, the reference sheet isn't going to help you much. But the reference sheet is there to remind you, to give you if you forget the details.
Well, I have I want to share a clever way of doing it.
Okay.
Maybe should we clear off the screen? I'll
Uh,
show you.
yeah. Okay, the way you're doing it, is it related to any other method on the screen?
No,
Okay, so that's good. So let's clear. So,
completely different.
okay, great. Okay, so let's clear all drawings, everyone.
Yeah.
Clear. So wait, the answer is 16 times 9, which is what, 144? I think so. Isn't 16 times 9 144? I don't know. We'll do that at the end. We don't really care about the ends. Okay, go ahead.
64. There's 16 times 9. Yeah.
16 times 9. Well, 16 times 10
9.
minus 1. So it's 160 minus 16, which does
Yeah,
seem to
yeah.
be 144. So the answer is
All right.
144.
Okay, here we go.
Yeah.
Here we go. So, what the idea here is, imagine that you extended this line and extended this line and closed it off like that. Closed it off like that.
Okay.
And then drew this line here. And the same thing up here.
Right, so you're doing a box. You're doing the volume of a box and taking a fraction of it.
Let's see, how do we do this? Yeah, same thing. Imagine the
nice straight
prism
lines.
Imagine this prism were encased. Oops.
Right. So you
Out
were
of
saying,
proportion
you were saying
there.
that it's a quarter.
We're
of
encased
it's a quarter of
in
the
a
thing.
square box, like that.
Right. So does that mean it's a quarter?
Yes.
It's a quarter of the volume of 8 times 8 times.
Yeah. A quarter of the volume of a box.
Right.
That is 8 by 8 by 9.
Oh wow, that's a smart way of doing it. Wow.
And then so once you get the 8, and the 9 divided by 4, then you have
yeah, it's 144.
Yeah, 144. You have 16 times 9, or you have 18 times 8, and figure it out, 144.
So Seth is invoking symmetry. Right. Yeah. Very, very powerful method. Really powerful method of invoking symmetry. Wow. That's a really clever way of doing it, Seth. Would that have come to you the first way of doing it? Well, or do you think you would have gone formula?
Well, what formula? The volume of a rectangular solid is the...
No. Instead of invoking symmetry, do you think you would have done it the way that most people will do it, where you take the volume?
I don't know about most people, but I did it the way the two of us did it.
Yeah, okay.
I didn't think of doing it this way until
a smart way of doing it.
We did it by the method you described.
Right. When you see circles, you always do that when you have, let's say you want to do the volume of a half of a semicircular thing like a loaf of bread. You always do the whole circle and you divide by 2.
Yeah.
But this is even more clever. Okay, so should we see?
So I say approach here is that when you're, say, if you start doing it a way that has a lot of calculations, or you think of a symmetry.
Yeah.
That's a good idea then, to simply go with the thing you've discovered about the symmetry. It will lead you to the answer quicker.
Right. Yeah.
Giving you more time for later questions.
Right. Sometimes when you have a triangle, it may make sense to turn it into a parallelogram. Right.
Yeah, well, that's why, the triangle, the parallelogram, any triangle could be doubled to a parallelogram.
Right.
And that's where you get that's where you could derive the fact that the area of a triangle is half of the base times the height.
Right. Right.
because the area of a parallelogram is equal to the base times the height.
Right. Okay, so let's see how they do it. Clear all drawings. I'm sure they use formulas. After we show the, should actually, why don't we, before we do that, why don't we see if we could stop the share for a second and see if we could show the formula sheet that the SAT people give. Oh, wow, I don't see it. Okay, so I guess we won't. We'll do it with, oh, share open. Hold on. Where is the sheet? Yes, there it is. Here it is. This is the sheet that you will see on the digital SAT. There it is. So as you can see, you don't get a whole lot. You get something. You get the area of a triangle. You get the area. You get the 30, 60, 90 right triangle relationships. The special right triangle, the 45, 45, 90. But you do not. You get the volume of those different shapes, but you don't get the volume of a triangular prism. In fact, you don't get the volume of any prism, base area times its height.
Well, the rectangular solid is a kind of prism.
Sure, but it doesn't give you a more general formula, base area.
And the cylinder, because think of a cylinder as a circular prism.
Of course, but it doesn't explicitly tell you that it's the base area times the height, although that should remind you of it.
Yeah, I guess they don't. Yeah, they give you they give you the area of the base in terms of, they give the whole formula.
Right.
The whole
formula. Exactly.
Yeah.
Okay, so let's go back. So that's the reference sheet that you will get on both the, looks like it's the same as the non-digital and the digital SAT. Okay, just moving everyone around so that we're back here. Okay, so the answer was 144, right? Okay. Check. Okay. Now let's look at step-by-step solution. 5 steps. Okay, the volume of a right triangular prism of height h and base area a is that. Let's label the figure. Notice that the height of an isosceles triangle drawn from a vertex angle bisects the vertex angle of the triangular base. Wow, my God! Oh, that's a smart way of doing it. My God, that is a smart way of doing it. Looking carefully at isosceles triangle. Right. So that's where they bring in the ratio of S radical 2, which, by the way, you don't have to really know. You can use the Pythagorean theorem. Once you know this, wait. Oh, I see. That side is 8. Oh, that side is 8, so that's 4. Oh, so you never really have to know the 4 radical 2.
Yeah.
Because you can just cut the thing in half. That's actually a really good way of doing it. Too bad. Oh yeah, that is a good way of doing it. Do you see what they did? They noticed.
Yeah.
They used symmetry. They drew the triangle. They put an 8 here, and they went like this. And the area of a triangle is 1/2 the base times the height. This is the base. And this is the height. And it knows that this is 45, 45. Everything's 45, 45. So if this whole thing is 8, this whole distance is 8, then this distance has to be 4. Oh.
Joel, you missed the point. What they did was,
this distance has to be 4.
They got, what they did was they figured out that if you drop the perpendicular like that,
right? Yeah.
Whatever the length of that perpendicular was 4.
Yeah, because it's an isosceles triangle.
Now,
right.
What we have here is the whole base is composed of these 2 bases.
Right.
Each of the half bases is a right triangle whose perpendicular sides are 4. So you could figure it out by saying that the area of the whole base, I'm going to give you a different way of giving it, is equal to 2 times 1/2 times of 4 times 4.
That's right. That's right. That's right.
However, a more clever way is to realize that the area of the whole thing is equal to could be obtained by doubling this right triangle by sort of moving it over here. And then therefore you get the area of the two triangles together is equal to the area of this square. That's the 4 by 4 square.
Right.
So the area of the base is 16.
Yeah. Yeah, that's really a good way.
It's easier.
Yeah, the way
of course, the two formulas give the same thing.
Sorry. Yeah. So there are different ways. There are multiple ways to get the area of that triangle. So we showed at least 3, or there are 3 or 4 ways of getting it. This is a really, really smart way of doing it, because you don't have to do the Pythagorean theorem. So, okay, that's good. So
you avoid messing with square roots of 2's.
Absolutely right. Yeah. That's the better way of doing it. Okay, great. So then you get it. 8 times 4, and then that's it. Rounded to the nearest cubic foot. That's so cute. That's completely unnecessary. So, now we're putting our introductions at the end. So, we are the Brothers Chaiken. We try to show you how to approach studying for the math SAT and doing SAT math questions. Seth is a PhD in math from MIT. He's a professor emeritus at SUNY Albany. I'm Joel. I have a PhD in mechanical engineering. And we, as you can see, what we do is we try to give you multiple approaches on how to do these SAT questions. In terms of approaching studying for the SAT, you should take the Khan Academy courses. Either just Google Khan Academy SAT practice, and you can do the digital SAT practice or the non-digital SAT practice, and speak to your guidance counselor about which test you are slated to take. Okay, yeah. Oh. Wait a second, that's wrong. Wait, rounded to the nearest cubic foot. Wait a second, that's completely wrong. It's rounded to the nearest cubic centimeter. Seth, good catch.
Yeah.
Good catch. Well, this is the difference between Khan Academy and SAT people. The SAT people almost never make a mistake, although occasionally they do, in a rare moment. Khan Academy doesn't have as great proofreaders. Ooh, Seth, why don't we, when we're done with this, why don't we report a problem and we'll become even more famous? Because we can report this as a problem. How does that sound? We'll do that off camera. Wow, good catch, Seth. Yeah, but in general, Seth's good. You always check the units. Sometimes they trick you with the units, but when they trick you with the units, they usually bold the unit to warn you that this is a trick of a unit. Here they didn't bold anything, and they didn't play any games, but be careful of that.
This is in the explanation. I hope, we didn't notice. I think we didn't notice any typo like that in the problem statement.
I did look very quickly at the units to make sure all the units were consistent.
Yeah.
But usually when they pull a unit trap for you, they usually bold the units. Yeah. But not necessarily. So you have to be ready for that. I'm sure everybody watching this video has at one point or another gotten a problem wrong on either homework or a test because of the unit trap, because they switched a unit on. Yeah. So I guess that's it for today, right? Oh, yeah, please like us, dislike us, give comments. And if you have any SAT math questions, please email us at satmathquestionoftheday@gmail.com. And we hope to see you next time we have a video, which should be very soon, hopefully every day. Hey, everyone, have a great day.